So for this, we want to evaluate log base 10 of 1000, log base 3 of 1/9, and log base 125 of 5. So in each of these cases, what we're going to do here is think exponentially, but in reverse. So in our first case, what we can identify is that we're looking for a power of 10 that would give us 1000. Well, we have 10 cubed is equal to 1000. So this is the same as saying the log base 10 of 1000 is equal to 3, because a logarithm just identifies the exponent of the base, that value there, that gets us this value here. It's identifying exponents. That's what it looks for. It looks for amounts of time, given growth rates, and final values. It's reverse. So for our second example, then we would be looking at what power of 3 would give us 1/9, where we can understand here that if we want a fraction, it's going to be negative, and if we square 3, we get 9, so if we make that -2, we get 1/9. And as a result, we could say here that log base 3 of 9 is equal to -2, because 3 to the -2 is equal to 1/9. Oh, excuse me, not 9. That would just be regular 2, and that wouldn't be as interesting. 1/9. And then, finally, if we want to deal with our third case, we have really the same idea. We're looking at 125, and we're trying to identify what power of 125 would give us 5. Well, 5 cubed is 125, so the cube root of 125 is 5, which we can write with a logarithm as saying log base 125 of 5 is that exponent 1/3. Again, all we're doing here is reversing the flow of information. Give the final value, find out how long it took. Give the function output, find the original function input for an exponential. And the next thing we're going to talk about here is some of the more general basic things, basic properties we have with our logarithms here, where what we need to understand is that because logarithms always work as the reverse of exponentials, a lot of the things we get for how they behave happens to come from exponentials, maybe in a bit of a reverse manner, but it still works in a lot of the same ways for fundamentally the same reasons, as we'll see.